Welcome, students. Page 4 of the Chapter 3 review packet on transformations. So we'll go through and describe two unique sequences of transformations that map triangle ABC onto triangle DEF. So I tried, let's see, the first one I think I tried, was a reflection over the y-axis so that I could get orientation to be the same. Right now, the orientation is not preserved or opposite, so I reflected over the y-axis. Then we'll translate, I believe it was down 6. As far as proper notation, if I use symbolic notation, it's going to look like this. Lowercase r for line reflection over the x-axis, and then translation. You don't need this vector notation. You just have to have 0, -6. Okay? Then we get into this. Oh, there's a second one. I do need a second one. All right. So I reflected over the x-axis. Okay, but a translation wasn't going to map A to D and C to E. So what I noticed was, as I was kind of drawing these paths, actually C to F, I'm sorry. As I was drawing those paths, it looked like that was going to be the midpoint of those straight paths, and likewise for B to E. So it was a 180-degree rotation centered at the point 0, -3. So you'll see I said reflect over the line that is the x-axis, and then rotate 180 degrees, centered at the point 0, -3. And then here's the symbolic notation for that sequence. Capital R for rotation. Okay, now is AC equal to or congruent to DF? And explain, I said yes, because I can map AC onto DF using a sequence of rigid motion transformations. And rigid motion transformations preserve, and this is distance or length. Okay, so for number 12, again, I'm checking orientation. It is, sorry about misspelling, I forgot an E on those. Orientation is preserved, so I won't need any kind of line reflection. Or what I chose to do in the second sequence is I had 2 line reflections. So rotate 180, okay, that will center at the origin. We'll map A to D, C to F, and B to E. The second one is actually exactly like a 180-degree rotation. It's 2 line reflections. The first over the y-axis, yes, and then the second would be over the x-axis. Okay, and that is going to act just like a 180-degree rotation centered at the origin. So are those angles congruent? The answer is yes, because one angle can be mapped onto the other using a sequence of rigid motion transformations. Then just finish it by saying rigid motion transformations preserve. You could say angle measure, or you could say congruence. Doesn't matter, pick one. And that's it for page 4.